Hi. How's that sound in the back? Too close? Too far? All right, great. Quick show of hands. Did anyone see me talk about the STINGAR project last year here? Ah, there's a few people. Well, not here, but Round Rock. I mean, you know, it's the same thing. All right, so I'm going to talk a little bit about some of the background of what we're doing and a little bit about where the project's been and lessons learned, et cetera. First, I have to say that some of this work was funded by the NSF, and their opinions are not mine, and my opinions are not theirs, and the usual disclaimers from that. So here we go. I'm Jesse Bowling. This is my symbol. I defend nightmare networks. Who here has defended an academic network? Not you people. I know you people. Okay, a couple who I was not aware. And so you're probably familiar with some of the challenges in this space in that it's not just one network. It's like a bunch of different networks because you are an ISP for your students. You are a research network for your faculty. You're a business network for your staff. You have PCI networks. You have ICS networks. You have all the different things. And combine that with giant swaths of IP space and either no border protection or border protection at the border that just has an any allow. And you put all those things together and it becomes really interesting really quickly. So we had a lot of problems that came out of that. But in 2014, Duke sort of changed our approach about how we were doing things. We implemented automated defense with threat intelligence and deception, which basically meant that we were scraping a bunch of logs, generating IP lists, and then shoving them into the border to block them as quickly as we could. We realized once we started doing that, hey, these block lists might be useful for other people, so we just added some context and started publishing them on HTTP server and called that sharing threat intelligence, and that was helpful. But when we were getting started in this automated blocking, which was sort of frightening for some of our administrative folks, one of the things that was really easy to sell them was this idea about honeypots, right? Honeypots are a concept that are easy to explain to your leadership. You can say, like, hey, here's this system that no one should be talking to it, and if they are, well, then, you know, we should probably, you know, look more closely or maybe even just block them outright. And that was an easy sort of sell for getting into this whole thing. So we started doing that. We did that for a few years, and we had a lot of success. And we started talking with our colleagues and folks at other schools about it and asking them, you know, hey, here's this simple concept. Could you just build this loop, and it would be great? And we got a lot of different reasons why, that they couldn't do that or they had this in the way. And so we started asking ourselves what we could do to help folks build this same sort of loop. So that's where the STINGAR project came in. STINGAR is actually a backronym, Shared Threat Intelligence and Network Gatekeeping with Automated Response. And the basic tenet is that we help people collect data about attacks on their network using honeypots. We automatically share that data back to a central repository that all participating partners can pull back. And we also built some hooks to try and help them get this data into whatever protection devices they may have as quickly as possible. The basic architecture kind of looks like this. We started with Modern Honey Network. Anyone use Modern Honey Network? Yeah, a couple users, great. We got really excited about it, and we were using that to deploy all our honeypots. We did a presentation about it at one of our conferences, and then like as soon as my colleague Nick finished the presentation, the guy who was basically running the project left Anomaly Threat Stream, and it seemed like things were sort of basically becoming community supported, which was sort of questionable for us. So anyway, we decided to fork it and do some things that were really helpful for us, right? And so one of the first things we did was basically Dockerize all these little bits. So we broke out all the components of CHN or of Modern Honey Network. We forked it into Community Honey Network, started Dockerizing things. And there's a few major components here. There's the CHN server, which is basically the web server. And it uses HP feeds to communicate with all these different honeypot types that you can deploy. we built some, there was an HP Feeds log container that basically, dumps all these logs out so you can pull them into your SIM or do further analysis, have rich data on like the username and passwords that people are trying, HASSH signatures for people talking to cowrie honeypots, things of that nature. And we also added in a couple other containers that were really useful for us. One of these was an HP Feeds CIF container. Is anyone here, did anyone here try to run a CIF container or a CIF instance at any point? Collective Intelligence Framework? Few people. How quickly did you give up? All right. This was probably in like the V2 days, if I were to guess right? The massive Octospice was the GitHub repo that was in. It had challenges. Well, they made a version 3, Bearded Avenger, and it's actually a lot better. And they've actually spent a lot of time sort of testing things out and making things more stable, and it's definitely a vast improvement. Well, it also has a long tradition in higher education. So it was also originally an NSF-funded grant. The version 0 of that was an NSF-funded grant, and so there's a lot of sort of uptake of that in higher education. And so we wanted to leverage the tools that people were sort of already familiar with. So we built a little container so that as soon as the server saw any sort of IPs coming in, it would check to see if it had submitted it recently, and then if not, it would ship it up to this central repository using the API. So that data all sits up here. And then we built a Intel Feeds container, which would basically automatically talk to this shared repository, pull down everybody's data with a specified query. So like, give me the last 3 days worth of IPs that you've seen talking to anyone's honeypots. Put it in a 1 IP address per line format, and then republish it on an HTTP URL, which made it really simple for people to pull this into their Palo Altos as an EDL and then write a block rule, or pull it into your firepower device as a security intelligence list, and just take action on these things and have this stuff running 24/7. We were originally using an IPS device where the feeds would only update every 30 minutes. We actually found that if we looked at all the data that we collected and we issued a block for a particular IP address, and then we looked at the number of blocks that the device actually performed for those IP addresses, we found that the things that we detected ourselves, we actually only got a block for about 30% of those. And the reason for that being that the timing of those updates, that 30 minutes, was just way too slow. So people were coming in and they were scanning things, and in 30 minutes they were long gone, right? So we were issuing a block for people who had already left. So we implemented a black hole router. The folks at NCSA, the National Center for Supercomputing Applications, on their GitHub, they have a BHR-site, which is basically a lovely little project that gives you a database and a web front end and an API, and it knows how to use Quagga to talk BGP to your routers if you want to peer them with that. So the idea here was you set up a black hole router, and it can peer with your BGP up at the border, and you can say, hey, let's kill these particular /32 IPs, et cetera. We actually tested that a great bit, and we found that on a really shitty router with 700 megs of RAM, we could shove about 450,000 routes in it before it kicked to CPU mode, which, if you know anything about routers, CPU mode is a bad place to be if you're trying to pass traffic. So we didn't want to put everything in there, but our our IPS devices were a little bit slow for pulling those feeds in. So we sort of split the difference, and we built this container so that when it saw an IP, it would shove it into the black hole router, and it would keep it there for an hour, which should be enough time for everything to flow into the firewall that was pulling things off this feed. And that actually works. Really well. So basically, if you talk to a honeypot on our network, that data flows from the honeypot into the BHR to the black hole router, and you get typically about 2 to 3 seconds before your traffic gets dropped for the entire network. So that's a great little reaction, and then we block you for, say, 3 or 4 days after that, because we found that that's kind of the sweet spot in terms of how long you should keep something blocked. Let's see here. Did I talk about all the pieces? I think that's all the pieces. We have this option for sharing raw log data. You could see, you could trade your raw honeypot data with someone else if they wanted to federate with you. It's HP feeds, right, which is what that whole thing was designed to do. And then, of course, we've got the summary data, which is much pared down. It's just, hey, this IP at this time with this honeypot submitted by this partner. But this repository actually ends up being pretty good for investigative ad hoc queries as well, right? So if you're looking into a bunch of IP addresses, investigating something, you can just throw those up against the server and see what comes back and say, oh yeah, this thing was talking to Cowrie and Diana honeypots around the same time, that sort of thing. So it can help give you some clues there. All right, that's all the bits. But the nice thing about this setup is really you can do it in a bunch of different ways. So we're running a CIF instance that acts as a collector, and we bring partners in and we issue them an API key and they drop it in that container and it just shares the data automatically. But if you wanted to, you could set up your own one of these, right? There's no dependence on our infrastructure, and all of this stuff is in GitHub, right? So like if you've got someone who's willing to run a CIF server, and it really has become much easier, I promise, that you trust, you could start spinning up these CHN instances and trading that data up to the CIF server, and then everybody gets that extra visibility, right? And there's no callbacks, there's no metrics that come back to us. We're not stealing your data off the back end. I mean, it's all just there and free and ready for you to use. So while our project is highly focused on higher education, there's no reason that you couldn't do this for whatever your affinity group is, right? All of you could set one of these systems up and give it a shot and see if it gave you some value. Did I do more slides? Benefits. It's really low, no cost. I mean, we're doing everything with Docker, so it's basically we give you a Docker compose file. Currently, there's like a little file that has some environmental variables in it that gets volume mapped in. We're working to make that stuff more Kubernetes friendly. It's a really great way to take malicious traffic just right off the top of your network. There's no reason in letting these things talk to you. Again, that's a use case that's maybe more academic specific because we're so wide open with so many IPs. The other sort of thing is that we're building a research corpus for researchers. So one of the sort of carrots we put out there is that if your school is running one of these instances and contributing the data, we're building a big research corpus of this stuff, and anyone who's at your institution can use that same data to do research. Right now, it's pretty basic. There's not a lot of information there. I mean, it's got the information about the IPs and what kind of honeypots, et cetera. But our thought is that at the individual schools, people can marry that up with other data, and that can be a little bit richer, right? So like if you take all the scanning data for a particular week and you marry that up with your NetFlow data, one of the things that researchers are always wanting for their machine learning is we need a data set that's labeled, right? So you can use this as sort of a, we can label the scanning IPs because we know what they were and use that to help train, that sort of thing. We're also looking at, what we can do to grow that data set and make it more useful for researchers, but that's going to be sort of continuing work down the line. So what else? This is actually my favorite thing. This is what really got me interested in this project, was that whole idea of like there's a bunch of people who are not doing this automated cycle. It turns out that if we can convince them to set up this server and some honeypots and then feed the data from those automatically into their border and share that automatically, once that's up and running, there's nothing about this process that says you can't interject other types of data, right? It would be very simple for them to write a Splunk query for identifying some pattern of attack and then dropping that into a CIF client that can then submit it back up to the central repository with a different tag, right? So once they have these tools, all of a sudden it opens up this world of like, oh, hey, I could start blocking these things automatically, or hey, I could start sharing data about these types of attacks that we see. Or, hey, I can leverage this in my forensics process. Or it just opens up the eyes for a lot of people about what they could potentially do with this stuff. And, one of our targets has been to make this as simple as possible. And so we've actually had a lot of success helping schools that have no security people but they've got a network engineer who's also a sysadmin, who sometimes gets to wear the security hat because he just happens to know a lot about a lot of things. We've had a lot of success getting them up and running, get their stuff going, get them piped in, and they love it. Right? So let's talk about some lessons learned. Community matters. I've had a lot of people help talk about this project in other places, mention it to other academic institutions, word of mouth. We've really started to hit a critical point where, like, I'm getting leads for people who are interested in running this stuff that, you know, I didn't reach out to them as far as I know, or I didn't talk to them at a conference. It's probably a terrible conversion rate because I think I've done, you know, most of the first part of this talk, like, you know, 15 or 20 times in the last year. But community also matters for the support. We've gotten some PRs that have been really helpful to help get some features done that we really wanted to do, but we just didn't have time to do because we still have day jobs as well as doing this project. I mean, I like to say that I'm only doing Stinger all the time, but there is actually a whole other side of my job that, you know, takes attention every now and again. The other thing is that any feedback is helpful. Like, if a half dozen of you went home and tried to install this in your home lab and wrote back and said, this sucks because of X, Y, Z, I would love that. Because I'm getting some feedback about what's working, what's not, what piece of documentation wasn't clear, you know, all this sort of stuff, right? So, like, any feedback is really super, super helpful. Also, Matt Plessel at DigitalOcean, everybody here should buy him a drink or 12 because he's awesome and helps people out, and he really helped us out with some resources and gave us a lot of extra visibility really early. That was quite nice. So can I get a small hand from Matt? I don't even know if he's here somewhere. Yeah, Matt's great. Matt's great. What else? Our ops aren't free. Every time that someone has to stop and ask me a question about, you know, the documentation says this, but then I got this weird error, and every time I have to stop to go answer those questions, it's just a killer for the momentum, right? Because I'm trying to do the community stuff, I'm trying to do the support, I've got a couple other people who are helping out, but one of them is basically just eyeballs deep in code in a version 2, and I've got another who's got a full-time sysadmin job who's helping me keep the infrastructure up, and balancing all those pieces is really tricky, and there's a lot of things I'd love to do that we just can't quite get to when I have to email people to tell them to restart their stuff, you know, once a week. Pay the cost to scale. This is one that I really sort of screwed up in. Somewhere around a dozen partners. 5 minutes? Holy shit. All right. You should scale as soon as you need to. As soon as you see it, go ahead and scale. Don't put it off, because otherwise you'll just lose a bunch of data because you didn't scale when you needed to. And documentation, God, like, I know how many things I need to fix in the documentation, and I keep not getting to them, and I keep paying the price for that, so don't do that. Yes. 10 minutes. Oh, well, that's a totally different thing. Small heart attack. Selling the suits. Man, I walked into a room with 15 CIOs, and I had 30 minutes to talk to them about this project, and I got more installs out of that 30 minutes than I've gotten out of anything else. And, I mean, it's pretty obvious, but, like, they set the priorities. So if they're sold, they're going to go ask that engineer, how's that Stinger project going? And guess what that engineer is going to do? He's going to make sure that Stinger project gets installed and up and running, right? So that's really great. But I still have to sell the engineers, and I have to make them comfortable, too, because if they go back to the CIO and they say, well, yeah, I know you're really excited about it, but it's a big flaming pile, well, you know, that's not going to get done either. Yeah, when the gods wish to punish us, they answer our prayers. That is also known, this slide is also known as leadership attention cuts both ways. It's really great because I get to go to awesome conferences and say, like, hey, I'm talking about Stinger. So I get to go to conferences and talk about Stinger, and that's pretty awesome. I get a lot of latitude of resources, so I can be at work and be like, I need this person because Stinger, and I can get some stuff done, and that's really, really nice. The downside of that is that your leadership may have a completely different vision of what Stinger is, right, or what this project is, and now you have to sort of balance and gently nudge and try to, curb things towards what you really had in mind. And it's fine, to go a different direction because, I mean, obviously what they're seeing matters. But it's just, I list it as a con because that is an extra pressure and extra sort of layer to your decision making and what you're having to do with this sort of thing. There's also the possibility to get stuck in the middle of these political battles. Where, hey, I'm just here and I'm doing this Stinger thing and my CIO is super supportive and appreciates this community effort, but then there's some other piece of the organization that's like, hey, this is great, let's put a patent on it and sell it. And that's a very different beast than what we're sort of promising people and what we're trying to work towards. I think the NSF money thing will keep that from happening. But, still, I mean, there's those sorts of pressures that are sort of starting to come at you and distracting from what you're trying to do. And then I just wanted to finish up with a little bit of data because when I did this last year, I had managed to spin up, I think, 4 partners, one of which was us, in the month or so that we had been going. So now we've got 25 schools involved. We've got maybe 170 sensors. I actually have no idea because we don't get stats back from the individual units. I just have to go around every now and again and say, hey, how many honeypots are you running? I know how many we're running, but I'm just sort of guessing at the rest. And in December, on 30 days of data, we saw a little over 500,000 unique IP addresses over that period of time. What's interesting is we probably see about 70,000 unique IP addresses per day, but then when you take that out to like a 3 or 4 day feed, that ends up to be like maybe 130,000. So there's a lot of these things that are just sort of like hitting day after day after day. One of the areas we'd like to explore is, building that sort of, we call the people who end up on these things bad actors. Like we have a bad actors feed. We also have a most wanted feed. How many times, how many 7-day periods did these IP addresses show up on this list? Turns out there's quite a few that actually show up there. About 20% of the IP addresses that are seen by one partner are seen by another partner. And that's not bad overlap. When we do see that overlap, it typically takes somewhere between 19 and 24 hours for them to go from one partner to another. So these things are still moving fairly quickly. It doesn't factor in the automatic blocking. So we probably have about a third to a half of the partners have matured to the point of where they're actually doing blocking based on this data. And for those, if it hits one partner, that data is going to get shared. It'll, depending on how quickly they're pulling feeds, typically every 5 minutes. Let's say it takes them 5 minutes to put that block into place, and they block it for 3 or 4 days. We'll never get a hit on their honeypot for it, right? So we're sort of missing some of the visibility once we started taking action. This is just another view of some of that same data. It's a log chart, but still right now the vast majority of those IPs are only seen by one sensor. But again, that doesn't take into account the fact that a lot of people are blocking on this stuff. Benefits. Here's a partner who was looking at 24 hours of their own honeypot data and doing blocks on it, and they were getting about 3.5 million connections a day that they were blocking. Then they started adding everybody's data in, and they had about a 3x jump in the number of connections that they were blocking per day. And then they extended their blocking list to 4 days from 24 hours, and they got another 3x jump. And the reason that this is so spiky up and down, these are all the places where SIF broke. This is where SIF broke. And so the feeds started falling off, and yeah, okay. It's actually much more flat now, but this is an old graph. What are the benefits? We were blocking like 10 million connections a day with our vendor-provided threat intelligence lists. Now we average about 250 million connections a day. when the Mirai botnet was really kicking, that was like 2.5 billion connections a day. And that was a really nice stat, but it's been so long since that was the case that I've adjusted this slide. But we saw a really big benefit. But probably the thing that we like the most is that we reduced the number of IPS alerts by 85%. So month over month, 85% of our IPS alerts no longer flowing into our per gig SIM and not filling up the screens of analysts, just all that noise just went away. And that was a really nice benefit for us. And again, 70,000 or so unique IP addresses a day. That's really just from the STINGAR project. When we add in the other things that we're doing that we share, not through the project, but differently, that probably pushes up closer to, 90,000 IPs a day. We're not pushing some of the other types of detections we're doing into that shared resource because, we're selling people on honeypots, we're bringing them along, we're letting them understand it, we're trying not to make things complicated, right? So anyway, future work, not a promise, forward-looking statements, things may change. We've still got some Python 2 laying around in those old projects that has to get ripped out. We're in the process of that. We're trying to get Kubernetes support so that we can just really scale these honeypots out, especially in some of the cloud providers. I'm trying to figure out how to do some misfeeds in a way that doesn't make people's missed databases cry. I think I'm probably just going to do a feed where people can just pull in a set amount of time to do correlations or to get that sort of thing out of it without actually adding a bunch of context. We do have a version 2, which I kind of wanted to show some screenshots for, but we're not quite to the alpha product at the end of January that we had hoped for. But that is coming along, and that's going to be a complete ground-up rewrite of all of it. That's the back-end architecture, the way the data gets shared, the front end, all of that stuff has changed. In the long term, expanding that research corpus, looking for more grants to keep us going with this project. We've got I've got another year on one grant and another 2 years on another grant, so this is going to be something that's going to continue for a while, but we're already talking about other potential opportunities, and so we want to keep this going for as long as possible. Regardless, we get such operational benefit out of it that we'll probably get to keep this going even without the grant money. So you could build your own. I mentioned that. I mean, between these two links, you could spin up the honeypots, and you could spin up your own CIF instance, which one of my teammates has gone ahead and put into a container, and you could sort of get started with this and play around with what would sharing look like with your own folks. And I think that would be awesome if people could do that, because we're really focused on the higher education space, and because of the research corpus bit, we're trying to keep it that way. But I want to find ways to involve more of you or give the benefit of what we've done to you all if you can find some benefit. So yeah, that's it. That's pretty much all I got. All right. Can I convince anyone to run this stuff? Anyone want to be brave and stick up your hand and try this out? Anybody? No? Taker? All right, I got one taker. Great. That's about my usual conversion rate. Anybody else? Questions? Uh-oh.
Hey, so I'm sorry, I missed the beginning of your talk, so I apologize if you already answered this, but sure. What happens if this HoneyNet was scanned by spoofed IP addresses?
It's a great question. We intentionally, out of the box, don't turn on any non-TCP services. and all the honeypots that are supported in the CHN project require a full connect before they're going to issue any sort of logging about it. Because that was definitely a big concern. There's a couple of them that do have UDP services that could be turned on. We don't turn them on in any of our documentation. Someone could do it, and they could potentially start feeding some bad data into the project. But thus far, most of our partners have been happy to sort of go with the configs we've given them and run the services that we sort of put out there by default. We haven't had anyone get too adventurous in that space.
Okay, cool.
But yeah, that's an excellent question.
What would be the difference between this and like gray noise? Is this like the free version of gray noise?
I had some great discussions with Andrew Morris about gray noise, and I think one of the big differences is he's got hundreds of thousands of nodes spread out among all these different infrastructure as a service folks. So he's got some great visibility in that space. So he's got a little bit more scale there, but when I've looked at the data, like taking a list of what we've got and what he's got, there's a surprising amount of non-overlap, right? So we're definitely seeing things that they're not. And that actually goes back to one of the things that sent us down this road, which was when we took in a bunch of open source lists about scanners and we were doing blocks on those and looking at how productive those were for us, we found that usually single-digit percentages of those open source lists did we actually issue any blocks for. Now, that could be applicability or it could be timing, right? It could take too long for that stuff to come back. But on the flip side, we found one other school that was on the West Coast that was generating their own list of bad actors, and they happened to already have that data in an API. And they started feeding us that data, and we found 50 to 75% of the IPs that they were blocking, we were issuing blocks for as well. So we have this theory that higher education threats are, they're different and they're somewhat common across this higher ed space. What's really interesting to me, I'm starting to think that what's also important for higher ed is what else is located near them. For instance, I used to work at a university in Washington, D.C., and we saw a lot of stuff that was way outsized for the type of organization that we were. I've got another partner who we spun them up, and they happen to be located near a lot of military research stuff in their space, and there's literally nothing else happening really in that whole state. And as soon as we spun them up, they jumped to number 3 in terms of unique IPs per day that they were submitting. So I'm starting to suspect there's something about location that's important to all this stuff too. So anyway, I think I got to your question, maybe?
Yeah, no, that's a great answer.
Okay, awesome. Anyone else?
One more question.
From at least what we hear in the news, a great many threats are delivered via email. And so here when you're blocking IPs, what kind of threats are you blocking?
This is a lot of noise for the most part, right? These are your scanners, your opportunistic things, right? And so I just call it the background radiation of the internet, right? But I think the point is for us, we have so much open space that generates so much noise, like it really bogs down the team in trying to figure out, what should we be concentrating on and what we should be working on, right? This is an opportunity for people, especially when they don't have a full FTE, to knock down a bunch of this noise, like right at the edge, at a basically zero false positive way, that then frees up some resources for them to actually go deal with those phishing threats and those malware threats that are coming in by email, right? Like, let's let them not have to go deal with the compromised FreeNAS server in the graduate student's office over in the research lab. Like, let's let them deal with the things that really matter.
So, and I have one slightly different answer on that. So we are, at University of Virginia, we're using this product, and we have not implemented bulk blocking yet, but we are hoping to do so soon. And one hope that we have, because we still have a bunch of services like SSH that are exposed to the internet, is that we might get some benefit, maybe not 100%, but some benefit from blocking some of those scanners before they happen to hit a vulnerable host on our network. But it's specifically for those services, RDP, SSH, Telnet, a few others, yeah.
Yeah, and we don't have the data for it, but anecdotally, the number of times we had to do that, incident response in the lab with the biohazard stuff, like go picking up desktops, the number of those things basically has dropped off to zero in our space, right? So a lot less wasting time doing that kind of work that doesn't provide a lot of benefit, and we've already learned that lesson, so let's not keep learning it.
So thank Jesse.